All right, in this lesson, we are going to take what we learned about adding and subtracting and multiplying polynomials and apply it to creating polynomial functions. So one of the key things that's different about when we just do the problems like we've been doing, simplifying expressions versus writing a function, is that a function isn't a function until it has a name, the name is like f of x, g of x. That's what represents the y variable. And so our names are going to look a little bit different. If we have this, if we're asked to do this, f plus g of x, we have to know that what that means for the procedure is that we're going to take the two functions named f and g and add them together, put them into standard form, and we want to make sure that our final answer starts with the name of the function, which will be our f plus g of x. And then if we have this expression here, then what we have to do is subtract the two functions. And if we have this expression for our function, then we're going to have to multiply the two functions together in order to create the new function and combine our like terms, put it into standard form, all of that kind of stuff. So the math is the same as we've been doing for the first couple of lessons, but the final answer will be in a function format. So that's the key thing, is paying attention to that detail of these problems, I think. All right, now, so some people were a little confused or can be a little confused by this. So I just want to point out that you are putting this into your notes, but this is given to you. This is the function that we're being asked to create. So when it says create the following function, this information, g minus f of x, is given to you in a problem. You're having to put it into your notes a lot of time to make sure that people are not working ahead and they're paying attention to the lesson. All right. So we have to understand when we look at this that this means that we're going to take our g of x function, because it's written first, and subtract from it our f of x function, because it's written second. Please be aware that this is not the same thing as f of x minus g of x. And the reason is our basic math tells us those two are not equal to. For example, if I take 5 minus 3, I get positive 2. If I change the order and do 3 minus 5, I don't get the same answer. I get a negative 2. And so that means that the order when subtraction is super important. So whatever is written first, you have to put that function first. A good strategy when you're doing these problems is to use a highlighter to highlight the functions in the given information. So like here it says I'm given this function f of x. And highlighting is a good strategy, because what often happens when I see people working out problems of this type is they lose the last term, like the minus 7. And so highlighting it makes your eyes see all of it more easily, and you're less likely to lose that last term. And then we also have our g of x function here, which ends at the plus x. So when I set up this problem, I want to make sure that I put that g of x function, which is these three terms, first. So I'm going to put it in parentheses because it's a quantity. So I have negative x cubed plus 4x squared plus x. Then I have my subtraction sign that's between them. And now I have to put my f of x function, which is these 4 terms. And I have to put parentheses around it. The parentheses around the first 3 are technically optional because there's nothing in front to distribute. But the parentheses are required around the f of x terms because we're going to have to distribute the subtraction sign before we combine any like terms, or we're not doing the math correctly. So it's super, super important to recognize those parentheses have to be there. And then before we combine any like terms, we apply the subtraction to each of these 4 terms, which, remember, when we subtract something, it's by definition adding its opposite. So what subtraction does is it takes the signs of the 4 terms in orange and it will change their signs. So when I subtract positive x to the fourth, it becomes a negative x to the fourth. When I subtract a negative, when I subtract a negative 3x cubed, it becomes a positive 3x cubed. So it's like plus 3x cubed. When I subtract a positive 5x squared, it becomes a negative or minus 5x squared. And when I subtract a negative 7, it becomes a positive 7 or plus 7. Now and only now should I combine like terms. And I can do my best here also to put my terms into standard form, which is required for my final answer, and it will save me some time. So remember, standard form is going to start with the highest power of x and work its way down to the constant term, or the lowest power of x. So here I see I have a negative x to the fourth, and I don't have any x to the fourths anyplace else, but that's my highest power, so that's going to start as my first term. And then I'm looking for the next highest power of x, which is my x cubed, and here I have a negative x cubed and a positive 3x cubed. Remember, this means negative 1, so I have negative 1 plus positive 3, which is 2, positive. So I get plus 2x cubed. Then I look for the next highest, which is my x squareds, and I have a positive 4x squared and a negative 5x squared. Positive 4 and negative 5 is negative 1 x squared, which we usually just write as negative x squared, because anything times 1 is itself, we just need the negative part. And then I have x to the first power, nothing else to combine, so I get a plus x. And then I have the positive 7 constant term, which would go at the end. Now, are you listening very carefully? Because what's coming up is super important. Here's where I see a lot of people go wrong. They think that this is their answer. This is not your answer. Because what I'm looking at right now is an expression. And I'm supposed to create a function. Remember what I said? We don't have a function until the function has what? Until the function has its name. And this is its name. So I need to make sure that it is what starts my answer. So I have g minus f of x equals my terms in blue, and now I have a function, and I have finished the problem. So that g minus f of x, that's like your y variable. You don't have a function until you have both an x and a y variable. Okay, and so that g minus f of x creates our y variable position. All right, so for this next problem, remember this would be given to us. This is the function that we're going to create, is f plus g of x. What we need to know is what that notation means. That it means that we are going to take our first function, which is f of x, and add to it the second function named g of x. And that information should also be given to us. And we can see that up here. And again, I do recommend that you use a highlighter to highlight each function so that you don't accidentally lose the last part of it. So f of x is defined as this trinomial, and g of x is defined as these two terms, which is a binomial. All right, so here I'm going to take my f of x function, which is these three terms, and write those down. So these parentheses are technically optional since there's nothing in front of those three terms. And then I have the plus sign, which is what I'm doing to these two. And then I have g of x here in parentheses, which is these two terms, negative 2x cubed plus 4x squared. And now what I have to do is remove my parentheses before I combine any like terms. So like I said, the first set of parentheses, they're kind of optional because there's nothing in front that is going to be distributed. So this will stay 5x cubed plus 2x minus 3. To remove the second set of parentheses, I apply the operation of addition. So I am adding a negative 2x cubed which if you want, you can just write as minus 2x cubed. And I am adding a positive 4x squared. So that just becomes plus 4x squared. Now I can combine my like terms. Again, also trying to put it into my standard form as much as possible, that descending order of powers, to save me work and time. So I have my 5x cubed plus my negative 2x cubed, which would be 3x cubed, and that should start. And then my positive 4x squared would be my next highest power of x, followed by this plus 2x, followed by the constant at the end of minus 3. And so again, is this our answer? Hopefully you're thinking no, because again, remember we're creating a function here, and this in blue is not a function because it doesn't have a name. It doesn't have a y variable. So where is that name? That name is here in our given information, the problem that we're doing. So we need to make sure that that starts our answer. So f plus g of x equals, there's our y equals, our name, and now we have a function, like so. All right, so here's our third example. So this piece of information in like a homework problem would be given to us. This is the function we're going to create. As it says, create the following function. So when we look at this with this little dot between them, we have to realize that that means multiplication. So this means that we are going to take the first function, which is f of x, and multiply it times the second function, g of x. So my f of x function, again, I recommend you use a highlighter to highlight each function. So here's f of x. It has 3 terms. And here is g of x. It has 2 terms. So my f of x is that trinomial x cubed plus 4x squared minus 5x times, and you can put a dot if you want to, but it's not required because 2 parentheses next to each other always means multiplication. And g of x is x plus 2. Now, I want to point out something here about our procedure. So when we multiply polynomials together, we know we have to distribute, which is the word we use to describe multiplication across addition and or subtraction. And we can do it this way. We can take our trinomial and distribute to the binomial, and that's perfectly fine. But, you know, we're kind of used to seeing the smaller one first when there's a smaller one. So multiplication is what we call commutative, meaning that the order of the multiplication doesn't matter. For example, if you take 3 times 2, we know we get 6. And if we change that to 2 times 3, we still will get 6. So if we want to, we could rewrite it with the x plus 2 first. So it's your choice when you're doing a problem with multiplication, which one you want to do first. Remember, you cannot do this with subtraction, because subtraction, if we change the order, we get a different answer. So subtraction, you're not allowed to do this, but multiplication, you are. All right. So now I'm going to distribute my x. So and you can write it out like this if you want to, but it's not absolutely required if you're comfortable without, this is okay to do, but you don't have to do this. And then I would distribute the 2 to my trinomial. If you can do that part in your head, that's fine. It's a good skill to develop once you're ready for that. So now, remember when I multiply powers of x, the exponent property that I'm using, which is called the product of powers, says that I would combine by adding, sorry, that should be another a, because they have to have the same base. So I add those exponents. And the exponent on x, remember, is 1. So when I take x times x to the 3rd power, 1 plus 3 gives me x to the 4th power. And then when I take x times 4x squared, I get plus 4x to the 3rd power, because 1 plus 2 is 3. And when I take x times my negative 5x, which also has an exponent of 1, that's going to give me minus 5x squared, because 1 plus 1 is 2. So now I'm going to distribute my 2. 2 times x cubed gives me a 2x cubed, and you can write it horizontally, or you can do what I'm going to do, which is line up my like terms vertically. And then my 2 times my 4x squared gives me a plus 8x squared, which goes here. And then my 2 times my negative 5x gives me a negative 10x, which doesn't match anything, so I'll put it there. And now I can just add my like terms vertically, and it's easier to see what goes together. So it's just a strategy of organization. So now I have x to the 4th plus 6x cubed plus 3x squared minus 10x. So now be careful. Is this our final answer? No, it is not, because we have an expression right now, not a function. So what is the name of our function? The name of our function was given to us here, what we were asked to create, f times g of x. So we want to make sure that our final answer starts with that name of the function, f times g of x, and that represents the y variable in our function. And now we've got our final answer. All right, so now we are going to go over another way to create a new function from 2 existing functions called composition. And composition combines 2 functions by a way of substituting one function into the other. Where this relates to our prior knowledge is like if we were asked to do or find f of 2. So if we were asked, well, what is f of 2? Then we know that this 2 in the parentheses is our x value. And let's say that f of x was equal to, x plus 3. So that would mean that f of 2 would become 2 plus 3, and we'd know it would be equal to 5. This is the prior knowledge that we have that composition relates to. But instead of plugging in a number like we do here, we have another function which has x's in it. So that's what makes it look a little bit different and require a little bit more of our algebra skill. So here it's demonstrating this idea. And we also have to learn how to make sure that we recognize the notation for composition. And there are a couple of different ways we can write composition in mathematical notation. This is one way. Notice the open circle between the f and the g. Not a dot like with multiplication. That open circle means that we're doing a composition procedure, which is a substitution procedure. We can also write it as an embedded. Both of these are often read or said f of g of x or f composition g of x. And what they both mean is that we take whichever function is written second and we plug it into the function written first. So here g would get plugged into f. G would get plugged into f. So what this is then demonstrated here. So here's our g of x. G of x is 2x plus 5. So what composition says is that we would take this 2x plus 5, and everywhere in the first function f we had an x, we would substitute those x's, replace those x's with 2x plus 5. So what it would look like would be f of 2x plus 5 equals the quantity of 2x plus 5 to the second power plus a 2. So that's composition, a substitution of one function into another. Once we've done this, then it's about using our algebra skills to simplify it and get it into standard form. So that's what we're going to look at now, is some examples where we're doing this. This right here talks about the procedure and the notation just in a different format. Your two different types of writing composition, either with the open circle or this embedded f of g of x notation. This is where it talks about the procedure for composition, where we substitute the second function into the first function, And then we do our simplifying using our algebra skills. And we make sure that we write that new function in standard form. And the name of this function will be that composition notation, whichever one of the two formats we've been given. All right, here we go. So this is the first example with composition. And notice this again, this portion, this f composition or f of g of x is given to us. You may be writing it into your notes, but as a problem, it would be given to you in an assignment or say like a test question. And again, it's a good idea to use a highlighter to highlight your functions so that you don't lose parts of them. So here we say we have our f of x function, which has 3 terms. And here we see we have our g of x function, which is just 2x. So now we have to make sure that we understand what this open circle composition notation means. So what this means is the same as is f of g of x. And I would recommend that in your notes you write down exactly what I am writing down. Don't skip anything, okay? Because I'm going to lead you through an organization procedure that is often helpful with doing composition problems until you become very comfortable with them. So we know these two are the same. So notice g of x is in our parentheses. So what we're going to do now is we're going to go to the given information and find what g of x is equal to. And that's right here highlighted in yellow. G of x is equal to 2x. So now I'm going to rewrite this as f of 2x. Okay? What this now tells me is I'm figuring out what is f of 2x. So now I need to know what does my f function look like. So I'm looking into my given information for f of x. And that I find right here and highlighted in blue, these 3 terms, x to the 4th plus 3x cubed plus x. So now I have to understand that composition is saying that each of these x's in my f function that I'm circling right now is going to be replaced with what I have in my parentheses, my 2x, which is g. So I'm going to put a 2x in each of these 4 positions. And now I'm going to have f of 2x equals. Now, anytime you do a substitution, you should put parentheses around the new quantity. So I have in parentheses 2x, and that is being raised to the 4th power, plus 3 times in parentheses 2x, which is being raised to the 3rd power, plus in parentheses 2x. So here, there, and there. X became 2x in this problem. Now I've got it all, I've done my substitution, so I've set it up. Now it becomes a problem where I have to use my algebra skills to simplify, which means remove parentheses, combine like terms, put into standard form, all that kind of stuff. So please remember, and this is again why the parentheses are so important, is that when we have a product like 2x that's raised to an exponent, the exponent property that we're using is called the power of a product. So it's like if I have a times b to an exponent, that exponent is applied to all factors inside the parentheses. So this is like what we did in our volume, like when we were, raising, like squaring both our number and our units, like inches. We squared both. Same thing here. So we are going to raise to the 4th power the 2 and the x. So we have 2 to the 4th power times x to the 4th power. 2 to the 4th power is 16, so this becomes 16x to the 4th. Here we have plus 3 times. The 2 is to the 3rd power, and the x is to the 3rd power. Again, follow your order of operations here. Order of operations says I do exponents before multiplication. So I have to do 2 cubed before I multiply by 3. 2 times 2 times 2 is 8, so this is 3 times 8, which is 24. So I get plus 24, and that x should not be to the 4th, it should be to the 3rd. Sorry about that. X to the 3rd. Now this is like having an exponent of 1. And anything to the first power is itself. So this just becomes plus 2x. So now I look to see, well, do I have any like terms? Is it in descending order or not? Here I don't have any like terms. Here I've got it in descending order. Exponents 4, 3, and then 1, which is good. Am I done? Nope. Because when I'm doing composition, I'm always creating a new function. And so that function has to have a name before I'm done creating my function. And the name is what was given to us right here, that composition notation. So I want to make sure my final answer starts with that. F composition g of x equals, and then what's in blue? 16x to the fourth plus 24x to the third plus 2x. And there's my new function this way. Okay, let's go ahead and take a look at this final example now. So here we have another problem that we have to recognize. So this is our second example for composition. This portion, this g of f of x, would be given to us. So when we look at this notation, we have to recognize this means composition and know what that procedure is. I would recommend in your notes you also write that this is the same thing as if I had g with an open circle and then my f. So some people mistakenly think f is always first. That's not true. What's important to understand is whatever function is written second, that is the one that's always getting plugged into the function that's written first. So in this problem, our f function is going to be substituted into our g function. So we always have to pay attention to, in the given information, which one is which. So here our f of x is x plus 1, and our g of x is x cubed minus 3x. So what I'm going to do is now find my f of x, and that's what goes inside my parentheses, and that's this x plus 1. So this now becomes g of x plus 1. So now I need to know, what is my g of x function? What is g of x equal to? So in my given information, g of x is equal to x cubed minus 3x. So composition tells me that what I have inside my parentheses is going to replace or be substituted in for each of the x variables in this g function. So each one of those is going to become that x plus 1. So we have g of x plus 1 equals the quantity of x plus 1. Always put parentheses around a substitution quantity. And that x plus 1 is to the third power minus 3 times in parentheses x plus 1. Once we've done our substitution, we now use our algebra skills to simplify, to remove parentheses, get like terms combined, put it in standard form, all that kind of stuff. And again, you have to follow order of operations, and you have to follow correct algebra procedure. So for example here, order of operations would tell me I should do my exponent first, which is this x plus 1 to the third power. Now be careful here, because if I have, like here, a plus or a minus, addition or subtraction, I cannot simply distribute the 3 like I did before. That's not appropriate. It doesn't work mathematically. So if you recall, we did a problem like this x plus 1 to the third power in an earlier lesson where we learned that we have to use what to the third power means, which means times itself 3 times. And we also learned that when we multiply more than 2 things, we still have to start with 2 of them. And then we take the answer to that and multiply times the third. So we have to multiply 2 of our x plus 1s together first, take that answer times the third x plus 1. And the reason we can't just distribute the power of 3 is because we have to distribute x plus 1 to x plus 1. So that's where the distributing happens, not at the beginning, but here. So when I take x times x plus 1, I get x squared plus x. And then distribute the 1, it gives me plus x plus 1. Combining 1x and 1x, that gives me x squared plus 2x plus 1. So now this trinomial is going to be multiplied times the third x plus 1. And I have to distribute here again. So now, distributing the x to my trinomial, I have x to the third power, because my exponents of 1 plus 2 would give me 3. X times 2x would give me plus 2x squared. X times 1 gives me plus x. Now I'm going to distribute the 1. 1 times x squared gives me a plus x squared. 1 times 2x gives me plus 2x. And 1 times 1 gives me a plus 1. So now, remember, x cubed, and then this is a 2 plus a 1. 2 plus 1 is 3, so that gives me plus 3x squared. This becomes 1 plus 2, which is 3, so plus 3x plus 1. And here, be careful. This is where being organized and as neat as possible with your work is important. Because I do see people who think, whew, okay, done. Here's my answer. But wait, that was just the first part, remember. The x plus 1 quantity cubed. We still have this part to do, where we're distributing a negative 3 to this x plus 1. And so this becomes negative 3 times x, which gives me a negative 3x, and a negative 3 times 1, which gives me a negative 3. And now I'm going to bring down those. So minus 3x minus 3. Now I'm going to look for my like terms. Now I'm going to have pretty much close to the end. I'm getting close now. So my like terms, I have my x cubed, no other like terms. My plus 3x squared, no other like terms. Then I have a plus 3x and a negative 3x. So remember, a positive 3 plus a negative 3 is 0. That means I don't have any x's, because anything times 0 is 0. So that's gone. And then I have a positive 1 plus a negative 3, which does give me a negative 2 as my third term. So now, am I done? Nope, not quite. Because remember, what we're creating here is a function. Does our function have its name yet? No, it doesn't. So what was that name? That name is the g of f of x. So we bring that down and make sure that our final answer has that in front. So we have g of f of x equals, and now we have our new function in its standard form to finish it up. All right, so that finishes up also this lesson.